page is that? 166. 166. Okay.
165.
Yeah, that actually works. That's 160. That's okay. So do you remember we graphed some and we were talking about where the zeros were, but sometimes it didn't cross the x-axis and so there were no zeros?
Attention, if you go to Burdett or you're leaving today for cross country, you need to go ahead and report to the auditorium for pictures.
Okay, it didn't cross the x-axis, so it had no solutions. Well, it actually does have solutions. They're just not real solutions. So we're going to look at, today, we're going to look at the set of numbers that make up those solutions when they don't cross the x-axis. That's what we're going to look at today when we talk about complex numbers. We're not going to get into solving them today with complex answers. We're just going to work with the numbers, adding them, subtracting them, getting familiar with them. We'll actually use them later. Today we're just going to figure out what are they, okay? All right. All right, so far everything that we've done has been the set of real numbers, okay? Everything had a real solution. And if it didn't have a real solution, we just said it was no solution, okay? But it actually does have a solution. It just has a solution within a set of not real numbers. If you look at x squared equals negative 1, does x squared equals negative 1 have a real solution? Why not? Right, square numbers don't equal a negative. What happens when you square a number? Right. Something times itself, that's what squaring means. So if you have a negative times a negative, it becomes a positive. And how do you get a negative number in multiplying? Like, what's a negative answer come from when you multiply? What times what? Right, a positive times a negative. Two different numbers being multiplied together. So there's no way that I could square something and come up with a negative 1. It just doesn't happen, right? Because negatives are positives times a negative. So is there a real number solution? No. There's not. Because negatives come from multiplying. Positive times a negative, and squaring a number times itself. I'm just going to write on my guy's face. He looks like the kind of person that has a face tattoo. So I'm going to fulfill his dream.
Right after you took that picture.
Yeah, I'm going to fulfill his dream of having a face tattoo. So, an imaginary number. So, what does this have to do with an imaginary number? Imaginary number, we call it I, is a number such that I squared equals negative 1. Right? I squared equals negative 1. So, if I squared equals negative 1, I equals the square root of negative 1. I equals the square root of negative 1. So if you have a negative inside that square root, now we can find a value for it. Now we can say, okay, it may not have a real square root, but it does have a square root. It's just not real. All right? Now let's look at this chart. See the chart at the bottom of the page? What does I equal? Square root of negative 1. I squared equals what? Negative 1. Okay, those two were gimmies. Now you get to start figuring it out. I cubed. Okay, I cubed is like I to the first power times I squared. What's I to the first power times I squared? What's I squared? And I to the first power is the square root of negative 1. So it's a negative square root of negative 1, or it's a negative I. You could probably, what I wrote off to the side, you could probably fit that in that box on your page. I don't have room for that. Alright, what about I to the fourth? What's I to the fourth going to equal? Well, if I could split this up into I squared times I squared, what's I squared equal? Negative 1 and negative 1. And what's negative 1 times negative 1? What? 1. Positive 1, right? So I to the fourth equals a positive 1. Alright, let's look at I to the fifth. I'm going to break it up into I to the fourth times I to the first power. What's I to the fourth? And I to the first power? Okay, what's 1 times that? That's going to be the square root of a negative 1, or just I. Alright, what about I to the sixth? I break this up into I to the fourth times I squared. What does that simplify to? Who is it? 1 times negative 1, that's 1. That's negative 1. So what does that equal? Negative 1. How about I to the seventh? I to the fourth times I to the third. What's that going to equal? 1 times negative I, or a negative I. Good. I to the eighth, I could make that I to the fourth times I to the fourth. 1. Right? Okay, good. Is that a 9? Okay. Alright. So let's go with a 4, and a 1. what is this going to equal? 1. This is 1. That's 1. This is negative, or square root of negative 1. So that one equals I. 10th, I could go I to the 4th, I to the 4th, I squared. So what's that going to equal? Negative 1. Right, 1, 1, negative 1. What do you think this one's going to equal? Do I have a guess on what I to the 11th is going to equal? 1. Yeah, well, what's going to happen here? I'm going to take out 8, right? And then I'll have 3 left over, which is negative I. So what's going to be I to the 12th? 1. Yeah. So what pattern are you seeing here? Taylor just said it. What pattern are we seeing? The same how? How many? Right. It repeats every 4. So on the next page, I'm going to keep this chart up here, but on the next page it talks about I to the power of 99, I think. Is it 99? I don't want to sit there and figure out I to the power of 99. So if I know that it repeats every 4, what could I do instead? What's a shortcut that I could use? I don't want to write out 99 and then like figure out how many 4s there are. Let me ask you this question. Is it about how many 4s there are, or is it about how many are left over? Because here I had one group of 4 and 1 left over, and the answer was I. Here I had 2 groups of 4 with 1 left over, and the answer was I. One group of 4 with 2 left over, negative 1. 2 groups of 4 with 2 left over, negative 1. Is it the amount of groups of 4 that are in it, or is it the amount that's left over? It's left over, because what are those groups of 4 equal to? 1. And does multiplying by 1 change anything? So if I'm multiplying by 1 10 times or 10,000 times, does it matter? What matters? What's left over? Right. What's a big boy, big girl word for what's left over? Remainder. Yes.
Sorry for the interruption, but 10th grade, if your last name starts with A through L, report to the auditorium to have your picture signed. 10th grade, A through L.
Just let us know here.
Yeah, I took this question. Okay, so if it's about the remainder, then this means we have to divide like the old-fashioned way, because we need to know the remainder. So 4 goes into 9 times. 4 goes into 19 4 times. I don't care about this. I care about that. If I to the 99th has a remainder of 3, then what is I to the 99th equal to? Negative I. Exactly. Negative I. It's not about the number that the answer is. It's about what's left over. What's left over is determining your answer. Okay? I have a few I'm going to get you to try. And then we'll stop because I don't want to do too much without the rest of the class in here. Try those four. On 24, what's the remainder? There's not a remainder, right? So what's that one going to be? It's not going to be I. It's going to be 1. Yep, it's going to be 1 because it has the no remainder. It has an exact factor of 4. Okay, 73, what's the remainder? 1. It will be I. Yes. Very good.
Okay.
You need to memorize that I equals I, or the square root of negative 1. That I squared is negative 1. I cubed is negative I, and I to the 4th is 1. You need to memorize those. And you probably will memorize them even if you don't mean to, just because we're going to work with them so much. But you need to have those in your head. That needs to be memorized. I'm not going to test you on it or anything, but it will make your life so much easier if you get those memorized. Okay?